Good evening. My name is Sarah Dinwoodie, and I will be presenting the asphalt industry, paving the way to a sustainable future. The industry that I selected was the paving and roofing materials industry, with asphalt concrete as the subsector. Modern mixed asphalt pavement was introduced in the 1920s, and now today, 98% of the roads in the United States are asphalt. Hot mix asphalt is also used worldwide as a practical solution to water storage, flood control, and erosion. In order to put into perspective the value of this industry to society, here is an example. In the United States, the value of the highway infrastructure can be estimated to be between $700 and $900 billion. If the value of trucks, automobiles, and their associated stock are then added, this adds another $1,200 to $1,800 billion in value. Finally, if the value of aviation, public transportation, and other modes of transportation are added, the value of the highway infrastructure in the United States doubles, if not triples, the entire federal budget. The steps for manufacturing hot mix asphalt are as follows. Aggregates and recycled materials are mixed, heated, and dried. Next, the binder is heated and added to the aggregate mixture. All of the contents are then mixed well, and the resulting product is ready to use hot mix asphalt. Asphalt concrete is composed of approximately 5% asphalt cement, a derivative of petroleum, and 95% aggregates. The addition of aggregates makes asphalt concrete a very strong material that is capable of withstanding significant loads and excessive heat. There are three classifications of aggregates. Pit aggregates are typically mined and occur naturally. Processed aggregates are naturally occurring aggregates that undergo processing such as crushing or screening. Finally, synthetic or artificial aggregates undergo both physical and chemical processes. Mitigation of environmental impacts involves analyzing the production processes. Asphalt production results in the releasing of greenhouse gas emissions. Emissions are the result of three main processes: raw material acquisition, transportation of raw materials, and hot mix asphalt manufacturing. There are several factors that influence the extent of waste and pollution that an asphalt processing facility might have, including location, hydrogeology, material storage, loading and unloading, plant size, and duration and intensity of precipitation events. The energy crisis in the 1970s caused the United States to become increasingly aware of the need for conservation of energy and natural resources, which led to the practice of recycling asphalt. In the United States, more than 70 million metric tons of asphalt are recycled in a given year. The greatest and most important challenge faced by the asphalt industry is sustainability. Three key ways that the asphalt industry can improve its sustainability are as follows: repeated recycling of material resources, low-energy asphalt mix production and placing, and reducing emissions. The United States has practiced recycling of asphalt pavement since the 1970s. The main objective was to reduce the continuously increasing cost by reducing the demand for new materials. Recycling is beneficial because it helps reduce costs and preserve limited natural resources. Asphalt pavement requires 20% less energy than other pavements. Since 1970, the asphalt industry has put conscious effort into consuming less energy and producing less emissions. By 1999, the asphalt industry decreased its total emissions by 97%, while increasing productivity by 250%. High congestion results in vehicles consuming unnecessary amounts of fuel and producing excess emissions. Due to the ease of laying asphalt, it allows workers to repair roads and create new ones in a quick, cost-effective manner. Similarly, vehicles driving on smooth pavement consume approximately 4.5% less fuel than vehicles driving on rough pavement. The asphalt industry, like any industry, is continuously investigating new technologies. Such technologies include variations in mixing techniques, recycling heat absorbed by the asphalt, and infiltration for drainage. Warm and cold mix asphalts are alternatives to high energy consuming hot mix asphalt. A new initiative in Switzerland is the Surso Plus project, which stands for Sun Energy Recovery from Road Surfaces. The system would involve a liquid heat transfer and circulation system placed under a road, where it could recycle the solar energy absorbed by the asphalt pavement. Another alternative technology is open graded pavements. Open graded pavements utilize one size of aggregate, and once binder is added, the aggregates bind together but leave pores, which allow for the water to drain through the pavement. The benefits are not limited to helping with drainage issues. They have a higher percentage of air voids, which help to trap noise, reducing traffic noise by almost 50%. The asphalt industry has immeasurable value to today's society and should have a firm place in our future. However, like most forms of infrastructure, the transportation industry was hit hard by the recession. However, the demand for asphalt paving products helped to cushion the transportation industry's decline. In 2009, the American Recovery and Reinvestment Act was signed into law. The ARRA specifically benefits the transportation industry. The transportation industry received $48.1 billion under the Transportation Income Generating Economic Recovery, or TIGER grant. As an industry that has a permanent place in our future, and with such a significant investment being made by both taxpayers and the government, it makes sense that the money being used not only benefit the country's infrastructure, but that it is done in a way that preserves natural resources and protects the environment. Thanks for listening.